Okay, so we're going to do lesson 7.2, which is another way to solve system of equations. If you remember in lesson 7.1, we solved systems of equations by graphing them. Remember, we put each equation in y equals mx plus b form. We graphed the two lines. And where those lines intersected was that ordered pair, or was the magical ordered pair that was a solution to both of them. That's one way to solve an equation, a system of equations. What we're going to learn today is another way to solve the exact same type of problems. So there's three different methods that we're going to learn. We're going to learn graphing, which we already did in 7.1. Then we're going to learn substitution, which is what we're doing today. And then lastly, we're going to use elimination. Okay, so 7.2 is the substitution method. Now, I like the substitution method better than graphing because you don't have to graph. That's my favorite thing, because you don't have to get out a piece of graph paper and graph it and do all that. Graphing can be a little bit tricky because if you don't draw your lines perfectly straight, sometimes they cross at a different point, even though you've done everything right, okay? So substitution method kind of gets that out, that error part, and we can just plug it in and find out what x is, and then I have to find out what y is. But in order to do the substitution method, I know without a doubt that one variable, it doesn't matter if it's the x and it doesn't matter if it's the y, on one equation, because look, I've got two equations here, but one variable on one of these equations has to be by itself. So it has to say either y equals or x equals. If it does not, I cannot do substitution, okay? I've got to rearrange it in order for it to say that in order for me to do substitution. So all substitution is it's telling me I know what y equals. Y equals x minus 4. Now, I don't know, okay, y equals 2 or y equals 5 or whatever. I don't know an exact number, but I do know that y is equal to whatever x is, then take away 4 from that. Okay, so what I can do with substitution is this equation that I have right here, down here, I can take this y and plug in what y equals into it. So x minus 4. So this is how I'm going to solve this. I'm going to write 4x, because I'm taking this second equation here, plus, what did y equal in that first equation? X minus 4. So I write plus x minus 4 equals 26. Does everybody see what I did there? All I did was take this y and replace them with what y equaled in the first equation, which was x minus 4. So I took this exact equation, took the y out, and plugged in x minus 4. Does everybody understand why I can do that? Because it's what y equals, so I just plug it in. It would be the same thing as if I had y equaled 5, I could plug in a 5 there. But I don't have an exact number, so I plug in exactly what I know. Now, all I've got to do is combine like terms. What is this number in front of x? 1. So 4x plus 1x is what? 5x minus 4 equals 26. Now, what would I do? Because I'm trying to solve for x. Not yet. I can't divide by 5. I got to move something first. Add 4 first. So this cancels out. Add 4. And I get 5x equals 30. Now, what am I going to do? Now, divide by 5. And what does x equal? 6. Okay? An ordered pair is my magical solution, right? So, do I have an ordered pair yet? No, I've just got the x of the ordered pair. So I've got to find the y. And guess what you're going to do? So simple. I know exactly what x equals. So what I can do is I can take it in this equation right here, y equals x minus 4, and plug it in. Y equals, what did I say x was? 6. 6 minus 4. What does y equal? 2. So my magical ordered pair is 6, 2. Now, I could have gotten that same answer if I would have graphed it, just like we learned in 7.1, but I could also find that answer using substitution. Okay, so example 2. Now, remember, what I just said in the last example was, in order to do substitution, one of your equations, not both, just one of them has to say x equals this or y equals this. But one variable has to be by itself. Well, let's look at these equations right here. X plus 3y equals negative 11 and 2x minus 5y equals 33. Do either of these equations have x equals or y equals? No. So what I want to do is I want to get one variable by itself. So what I'm looking for is I'm looking for the one that's going to give me the least amount of work. So what I'm looking for is the variable that I can get by itself that I only have to do one step in order to get it by itself. Now sometimes there isn't one. Sometimes you do have to do more than one step. But everybody look, okay? And these two equations right here, the easiest variable to get by itself would be this x right here. And you say, how did you know that by looking? Okay, think about it. It's already x, so there's no number in front of it that I have to worry about. And what would I do to move the 3y over? Subtract it. And I get x equals negative 3y minus 11. Now it says x equals. See, that was one step. That's what I'm looking for. I'm looking for an equation that I can do just one step on, okay? So when it says which variable would you isolate, that means which one would I get by itself, I'm going to circle this x right here because that's the one I want to get by itself because that's going to be the least amount of work. Does everybody see why that is? Okay, let's say I decided, nope, I want to get this x by itself. Okay, not a problem. Let's go for it. What would I move first? I have to add 5y first. And then I get 2x equals 5y plus 33. Then what would I do? Divide everything by 2. And I get x equals 5 over 2y plus 33 over 2. Okay, do you see how that one was more work to get the x by itself? That's why I chose the one that I did first, okay? So that's what you're looking for. Technically, you can get any variable by itself. It doesn't matter. But you're looking for, okay, how can I save myself some time? Because I don't want to spend 45 minutes on homework when I can spend 20 minutes on homework, okay? So that's the whole point. So let's look at this next problem here. I'm going to erase all this, and I'm just going to circle the x because I know that's one, okay? Now, do you see any variable that stands alone, like that x did? It stood alone. Dominic? The negative y. But what does the y have in front of it that the x did not? A negative 1, okay? So, still, that is probably my easiest variable to get by itself. Because what would I do to get that y by itself first? Subtract 3x first, and I get negative 1y is equal to negative 3x minus 9, and then what would I do? Divide everything by negative 1. It's always easier when you divide by negative 1. Y equals 3x plus 9, okay? That's why I'd want to get that one by itself. Now, like you said, do you have to do what? No, you only have to get one by itself. So that's the only one I'm going to isolate. Because now that I know what y equals, remember, I take this and I go to this equation and I plug it in for y. Remember that? Okay? So this one would be the easiest variable to isolate. Okay, now we're going to put those two steps together. So combining the first example that we did, which was we saw that y equaled this, and so we plugged it in. Then, or I could get x equals this and plug it in. And then example 2, we had to figure out, okay, there's nothing that says x equals or y equals, so I have to get one. And then I can plug it in. So example 3, we're putting both of these pieces together. What do you think the easiest variable to get by itself would be? Dominic? Positive y, perfect. Because what am I going to do to get it by itself, Tommy? subtract 3x. Okay, because I want to get that y by itself. So I subtract 3x. And I get y equals, everybody should be writing this down, negative 3x plus 5. Now, do I have something that says x equals or y equals? Yep. I know exactly what y equals. It equals 3x plus 5. So what can I do to begin to solve for x and y? Take what I know at y equals and plug it into this equation for y. Now beware. This is your warning. Beware. What is this number in front of that y in that second equation? Negative 1. Write that there. Please write that there. Because if you don't, you're going to mess up. Anytime you have a number in front of y, that means this number is being multiplied by y. So when I plug in my 3x or negative 3x plus 5, I'm going to need to make sure that negative 1 gets multiplied by negative 3x plus 5. So I write 2x minus 1 times, all right, what I'm going to do now is I'm plugging in what I know y equals, which is negative 3x plus 5, and I know it equals 10. Now you say, Ms. Reber, why didn't you get a variable by itself in this equation? Because you don't have to. All you need is one equation. Now, what do I need to do here? First, well, can I add negative 3x plus 5? So I want to do distributive property first, okay? So I'm going to do 2x. Negative 1 times negative 3x is positive 3x. Negative 1 times 5 is negative 5 equals 10. Okay, combine like terms. 2x plus 3x is 5x minus 5 equals 10. What would I do now?
You
add 5 to both sides. Perfect, because I'm trying to combine like terms. So I've got 5x equals 15. Divide by 5, and I get x is equal to 3. Am I done? No. Because remember, the magical ordered pair is an x comma y, and I've got x, but I don't know y. But now that I have x, all the hard work is done. Because what I can do is I could take this x is equal to 3, go right to this equation right here, and plug in the 3 for x and solve for y. So I write y is equal to negative 3 times 3 plus 5. Negative 3 times 3 is negative 9 plus 5 is negative 4. So, you always want to write your answer as an ordered pair. So my ordered pair is 3, negative 4. Okay? Okay, so example 4, we're doing the exact same thing. I need to figure out what variable I want to get by itself, and then I'm going to do that, and I'm going to solve. So look at this problem right here. You decide which variable is going to be easiest to get by itself. Which one do you think?
X minus 4y equals 1.
Okay, and what in this equation am I going to get by itself?
X.
The x, perfect. Because all I need to do is what?
Subtract 4y. No, add.
Add 4y, because 4y is negative. So I add 4y, and I get x equals 4y minus 1. Now I know what x equals. So what I'm going to do is I'm going to take this 4y minus 1, and I'm going to plug it in my top equation for x. Now you say, hold on a second. The last two examples we did, the variable that we got by itself was in the first equation, and I plugged it into the second. Now this one, the variable I got by itself is in the second equation, and I'm going to plug it in for the first. Is that okay? Absolutely. It does not matter which one it gets by itself as long as the other one is what you plug it into. Okay? That makes sense? All right. So we do 2 times, what am I plugging in for x?
4, 1, negative 1.
No, do I know, remember, I know that x equals 4y minus 1. Then I just finished writing the rest of my equation. 2y plus 2y equals 3. What am I going to do first? Distributive property. 2 times 4y is 8y. 2 times negative 1 is negative 2. Combine like terms. 8y plus 2y is what?
10y.
Now what am I going to do?
You
Add 2. And I get 10y is equal to 5. What am I going to do now?
2. Divide by 10.
What does y equal? 1/2. Very good. Not 2, because 5 over 10 is 1/2. You say, oh, I got a fraction. I don't know how I'm going to deal with it. I hate fractions. They confuse me. Look, all we've got to do is plug it into this equation right here. So it's not too bad. All right, so let's do x equals 4 times 1/2 minus 1. Well, this is all you got to do. What's 1/2 of 4? 2. X equals 2 minus 1. What's 2 minus 1? 1. So my magical ordered pair, I like to call it the magical ordered pair, would be what?
Y equals 1. No, x equals 1.
Okay, but remember an ordered pair is x comma y. So how would I write it?
Oh,
1 and 1/2. Because remember, y is equal to 1/2, x is equal to 1. So this is my magical ordered pair that's going to be a solution. Okay, example 5. Look at what they've done for us here. We're just doing more of the same thing. But take a look. It's already x equals 2y. Hallelujah. I don't have to do so much work. So I already know that x is equal to 2y. So what am I going to do with that 2y? Plug it into the other equation for what letter?
y.
X, because it's x equals. So I'm going to do 2 times what? 2y plus 6y equals 15. What's 2 times 2y? 4y plus 6y equals 15. What's 4y plus 6y?
10y.
What am I going to do now?
Divide by 10.
And what does y equal? 3 over 2, or 1 and 1/2, okay? What I'm going to do is I'm going to leave it as an improper fraction for right now, because when I plug it back into one of my equations, it's going to be easier to multiply with if it's an improper fraction, okay? So what I can do is look, I can plug that y in right here, and I can find x really simply. So I'm going to do x equals 2 times, what did I get y was? 3 over 2. What's 2 times 3 over 2? Basically, it's going to be 2 over 1. What happens? Cancel out the 2's. And what does x equal? 3. So my magical ordered pair is what? 3 comma 3 over 2. Now, if you want to write that as a mixed number, 1 and 1/2, you can. But it doesn't matter. You can leave it as an improper fraction. Okay? And that is all for solving by substitution.